Bismillahirrahmanirrahim. Assalamu alaikum students. Today we will learn how to plot the graph. So in the last week you have done this experiment which is Ohm's law, and in Ohm's law you have taken the data of current and voltage, then you apply the formula V over I to find the resistance. And then you find the average value of the resistance, that is 2.04 ohm. Now we want to plot the graph between current and voltage and then find the value of the resistance from the graph. So according to Ohm's law, you know that V is equal to I into R. This is Ohm's law. So we compare this equation with the straight line equation y is equal to mx plus c. So here c value is 0. So if c value is 0, c is called actually y-intercept. So if c value is 0, then our graph must start from 0, 0. This is our I and this is our V. If the c value is positive, then graph will start from here. And if the c value is negative, then the graph will start from here. Now, from this equation, if we compare these two equations, then V is along y-axis and I is along x-axis and R is M. So in the graph, this is your I-axis, this is your V-axis, and this is our line which is passing through 0, 0 due to this C is equal to 0, and R is M. R is M mean this is the slope. So you can take the slope by taking 2 points on the line, like this one, and this is your x1, this is your x2, this is your y1 point, and this is your y2. So slope is equal to y2 minus y1 over x2 minus x1. So in this case, our slope is your R value. So now we want to find this R value from our slope or from our graph. Now the question is how to draw this line. Before drawing this line, first we draw the points and draw the line. But before, we will take the scale on the graph paper. So this is the question. So you know that the graph paper is like this one. And this graph paper along x-axis has 20 squares. It is mentioned here on this graph paper. And this side is around 28, 26, 27, and 28. Okay, this is 28 and this is 20. So to plot the graph, first you have to draw x-axis and y-axis on the graph. Anywhere you can draw, but our graph must be a good graph. Good graph means it should be bigger, full page graph, like full page graph. So you can draw the x-axis line here. This is your x-axis line I'm drawing here. And the y-axis line you can draw here. So it looks good. So this is my y-axis and x-axis is I. X-axis is I and I is in ampere and V-axis is in volts. Now, after drawing these two lines, now measure the number of squares along x-axis from here. Now you can see it is 17. This, if you start from here, it is total 17. And if you start from here, then you can see that this is 24. Okay. So what we will do? We will use one formula. The formula is maximum value of the data along x-axis. So x-axis is our current. The maximum value of current is 0.5. So 0.5 divided by how many squares along x-axis, which we have measured, and again you can see that this is around 17. So I write here 17 and then see the answer. So if I divide it and then calculate it, the answer is 0.029. You can check it by the calculator. So this is 0.029 mean it's very close to 0.03. So close value, you should take more than this value, not smaller than this value. Okay, more than this value. Similarly, this is along x-axis. This is for I. Now for V, the maximum value is 1.1 and divided by the number of squares is around 23 or 24. So you can divide it by 23. The answer is 0.047. So you can see that 0.047 is close to 0.05, more than this value, 0.05. So one is here and one is here. No, our scale is adjusted. So it means each square is 0.03 in this side and 0.05 is in this side. So how I will write these values? So to write the values, what you will do? You will write here 0 and y-axis is voltage and this is 0.05, then 0.10, 0.15, 0.20, 0.25, 0.30, 0.35, and then 0.40, 0.45, 0.50, 0.55, 0.60, 0.65, 0.70, 0.75, 0.80, 0.85, 0.90, 0.95, and 1.00 and 1.05, and this will be 1.10. So this is our last point in the data. If you see this one, this is the last point. Now draw the points on the x-axis. So this is our x-axis. So this will be 0. First is 0.03, like this. So 0.06, 0.09, 0.12, 0.15, add 0.03 in previous value. So 0.18, 0.21, and 0.24, 0.27, 0.30, 0.33, 0.36, 0.39, and 0.42, 0.4, 5, 0.48, and this is 0.51. So now the scale is adjusted. After adjusting the scale, what you will do? You will do to draw the points. So here you can see in the data 0.1 and 0.18. So here you can see from this side 0.12 is this one. It is not 0.1, it is 0.10. Okay. So it is close to 0.12. So we will take it here around approximation. And 0.18. 0.18 is close to 0.20. So where is this one? It is around here. This is our first point. Okay. Up and here, a little here. Okay. Because it should be upper to this one, like this. And then 0.20. So this is 0.20. It is close to here. And go up and put the point 0.42. So 0.42 will be around here. This is your 0.42. Okay. After this, 0.3. So 0.3 is here. Now you can see this is 0.3. And the value is 0.63. So 63 is here. This is 65 and 63 surely will be down. So 63 is here around. This is approximation points. Okay. And then 0.4. So 0.4 is where? Now you can see that this is 0.39 and 0.4 will be a little above. And the answer is 0.8. So 0.8 is here. So you can draw here. This is 0.8. 5, but this is 0.8. Yeah, this one. And then 0.5. So 0.51 is here and 0.51 or close to 0.5. I am drawing the point and this is 1.1. So 1.1 is here. So this is my this one. Okay. Now we will draw the line and that line will be approximate line. So how to draw the line? So starting from 0, 0. Maybe it is not cover the whole page here, but I draw the line and you can understand from here. So this is from 0, 0. So draw the point and not all points are on the line. It doesn't matter. So draw the approximate line between these points, around between these points. Okay. So this is our line. Now you can see the line. The line is starting from 0, 0. Okay. Starting from 0, 0. Now you can take 2 points on the line. The points which you should take 2 points on the line, it should not be from this table. Not from this table. You should take yourself. So it's easy for you. The first point is this one. This is 0, 0. You can take. The other point you should take away from this point, not close to this point, which you can read easily. First see that point. If you cannot read easily, then take any point. So I think it's better you can take this point easily and this point you can take easily. So take this one. So if I take this one, then I draw the line here. This is line, and this is this point. Now you can find the slope. So to find the slope, what you will do? This is your x1 or y1 points, and this is your x2 or y2. And this point is what? 0.24 and 0.50. So y2 minus y1 over x2 minus x1. And this is equal to 0.50 minus 0 over 0.24 minus 0. 0.25 minus 0. Minus 0 means this one. And 0.24 minus 0. So you can find it by calculator. Now I use the calculator. 0.50 divided by 0.24. So the answer is 2.08. 2.08 ohm. So this slope is your R value. If it is for R1, then it is R1. So in the same pattern, you can draw other graph for R2 and find the slope. Although this point is very at the edge, so it's better you can take the scale, not 17, you can divide it by 16 or 15. Okay, it's better because the last point will be here. So in this way, you can get more good graph. Okay. So this is the way how to plot the graph and how to understand it. So in every lab, you have to plot the graph, and this is the method how to plot the graph. So this graph is easier than the other lab graphs because here we have not a 10 raised to power minus or 10 raised to power plus factor, and here also we don't have. If we have a factor, then we will include that factor to find the slope. I think you understand and clear this picture. Okay, thank you.